Okay. Good morning, good afternoon, everyone. Thank you so much for joining us this day. My name is Lilian Krug. Can you hear me well, Carla?
Yes, do you hear me?
Thank you. I'm the scientific coordinator of POGO, and I'm here today to host this webinar proposed by our alumni network project. The project is entitled A Global Study of Productivity, Deoxygenation, and Ocean Acidification at Selected Sites. It has been running since 2017 with about 13 participants from Latin America, Asia, and Africa. Main objectives of this project is to promote in situ and remote sensing data acquisition or observations in selected coastal sites in order to contribute to the global effort of monitoring the levels of ocean acidification and deoxygenation, but also to promote capacity building opportunities, which is why NANO Global Project started this webinar series. This is the 5th of the webinars we have been presenting since last year, and it is being recorded, so we will post this later on POGO YouTube channel. So if you don't want to have your face or your voice recorded, please refrain to use mic and camera. So today's presentation is by Dr. Carla Berghoff from the Instituto Nacional de Investigación y Desarrollo Pesquero, in Argentina. Carla is a research scientist specialized in marine plankton dynamics and climate change. She's working on a project with this name in South Argentina. A biologist with a strong background in carbonate chemistry. So she's also involved in the ocean acidification networks in Argentina, in Latin America, and she's the representative of the Argentinian node of this NANO Global project. So Carla will talk about how to start and maintain a carbonate system in situ observations to evaluate ocean acidification. Carla will present for about 30 minutes, Carla. And then we will open for questions. So again, if you don't want to have your face or voice recorded, you can use the chat box and I can speak out your questions to Carla. Thank you very much again, Carla.
Well, good morning, everybody. Good evening for somebody. Depends on the time zone. So, Lika, thank you for presenting me. So I'm going to start. We all are aware that we release excessive amounts of CO2 in the atmosphere. And we know that these emissions have been since the beginning of the Industrial Revolution. And nowadays we reach values that are higher than 400 ppm. This is the killing curve of a globally monthly mean CO2 in the world. And as you this is really updated from yesterday. And now we have 412 ppm. So it's really something. And this is caused mainly by our activities, our anthropogenic activities. And okay, this is about the atmosphere, but it's also about the ocean. And why? Because oceans, we all know that oceans play an important role in our lives, not only by giving you sources of food and work, but also giving us way to surf, the oxygen we breathe. And it has a complex interaction with the atmosphere. We know that oceans absorb CO2, and it's been more than 30 years since the community, the research community, is aware of the increasing levels, not only in the atmosphere, but also in the ocean. Ocean is responsible for absorbing at most 30% of our anthropogenic emissions. And community is aware that this increase in the atmosphere has impacts in the ocean, and CO2 has been rising since then. So, in one hand, this is good for our planet, because otherwise our global warming would be worse. But it also has negative impacts on the sea, and one of the most important is the reduction on pH. As you see in this picture, it has been shown in LAOCA and in other time series around the globe that the increase in CO2 is leading to a reduction of pH in seawater. So by saying that, ocean absorption affects its chemistry. And how affects its chemistry? It affects the carbonate system chemistry as a result of this increase in high CO2 concentrations. That leads to reduction in pH and also in carbonate ion concentration, which is one of the most important building blocks, as we say, for calcifiers, but also affects the capacity of seawater to buffer changes in its chemistry. So that's what is ocean acidification. And it's a process ongoing, and it has not only biological and ecological impacts, but also socioeconomical in the marine ecosystem services. Nowadays, this problem has been tackled all around the community, but it's under the umbrella of the Sustainable Development Goal 14, life below water, in Target 14.3. And it's important to understand that this umbrella is in all levels, not only in the scientific community, but on the citizens community. So, but what is carbonate system in seawater? We need to understand a little bit the chemistry to get the full picture of the issue of reducing pH and reducing carbonate ion. And a specialist knows that we cannot measure everything, but we have certain variables that can be measured to understand the carbonate system. And mainly there are four. We can measure the difference between the pressure of the gas in the different compartments, let's say ocean and atmosphere, which is here highlighted in yellow. We also can measure all the group of compounds that are generated by the reaction of CO2 and water, which is the bicarbonate and carbonate and the carbonic acid, let's say CO2 with a star, as we call in the community. And all of these compounds we can measure what is said dissolved inorganic carbon. Other variable that can be measured is the pH. As a result of these chemical reactions, the hydrogen ions released are measurable. And also there's another variable called total alkalinity. To be honest, it's tricky to synthesize the definition, but let's say it's a group of compounds that have negative charges that you can measure, and in order to understand what is complementing these bicarbonate, carbonates, and charges of these hydrogen ions. So saying that, we know that we can measure at least 4 variables to get a full understanding of the carbonate system. It's really important to collect variables, essential variables, to take the pulse of the ocean. That's how we can get an insight of the ocean acidification problem and understand the impact that these changes are having in the marine ecosystem. And Maybe this talk is going to be a kind of personal. I'm going to tell, maybe I'm going to be more focused on my experience, which is small, but still I'm going to share with you. The most important thing when you want to start measuring is to set your objective. What you want to do. You want to measure in situ, you want to do some experiments. Are you interested in modeling what's going on in your area? What is your main focus? Is your focus to know, to understand trends, multi-decade trends or variability? Are you going to be more interested in understanding the relationship between phytoplankton and its changes in high CO2, which is my case? Or you are more interested in or understand short-term variabilities? So this is important when you want to start a time series or to want to start your measurements in ocean acidification to set your objective. Of course, there is no when to start. As soon as you can, you need to start measuring. It's important. We are aware that ocean acidification is a global, is of a global concern. So we need to start as soon as possible. How? The hows are different among the institutions, the needs, etc. And where depends on if you're interested in measuring in the ocean or in coastal areas or on a dock. And in my case, it was kind of easy because we have a platform, a time series already running in our institution. EPEA time series, it's called Estación Permanente de Estudios Ambientales. It's been running officially since 2000, so it's been 20 years since we are running this time series, and it's a coastal time series located near the Mar del Plata coast in Buenos Aires province. And it has a really defined objective, which is understand the long-term variability of the plankton extractor and the oceanographic conditions to understand if there's some special events or some variability that we can associate to climate change. So for us, for me, when I start to thinking about running ocean acidification in situ measurements, the place was already being set. We are a huge group of more than 25 people. Sometimes we go on board on different ships. It's a ship time-based series. And when I started, I needed to understand which equipments do I need and which platforms do I need. And it's really important to understand this from the beginning, because at the beginning was kind of, what should I do? Should I put a sensor? Should I get a buoy? Okay, to get a buoy is really difficult for us, but the ship time base was already running. So my decision was to take discrete measurements of at least 2 carbonate system variables, because that's important to get the full understanding of the carbonate system. And okay, we decided to start the measurements, but there are several types of equipment that range from really relatively low cost, let's say for the science, to really expensive ones. Here I put a link if somebody's interested or maybe can ask me about the instruments and the sensors. IOCCP has a really nice web page on that. But at the beginning, we think about which equipment we acquire. You need to think about that it's gonna need to fit for your purpose. Let's say, okay, you have low budget. Let's start for something that is acceptable and the community, the ocean acidification community accept, and something that you can intercooperate with other peers. That's really important. Sometimes to reinvent the wheel, it's going to take more effort and more time And I think that when you start measuring, in my case, we decide to look at other time series, mainly in Latin America, because we have let's say, similar issues, political context, economical context, and also since we were starting, we really wanted to have a really nice connection with other colleagues to start our measurements. So something really important is we start measuring carbonate system in 2015. So it's only nothing, 5 years ago, but it's been a lot of process since then. And we were so lucky that we have colleagues from the National Hydrographic Service in Buenos Aires, from the group of Alejandro Bianchi, which is the most important researcher in Argentina dealing with a carbonate system. He was the first to study it in Argentina. And they were so nice and helping us to, by lending us an equipment that was measured total alkalinity and estimate dissolving organic carbon. It was an automatized closed salt titration system. Here in this picture, you can see me measuring at sea. They invite me some years ago to a cruise, and to understand how the equipment worked. And it was really important for us that connection to start. And so we start measuring in 2015, and then we decide we needed to acquire our own equipment, and we decide to start acquiring a spectrophotometer, a portable one, to measure on board pH. To get this equipment was crucial because we start to having in situ measurements with an acceptable quality. And we acquired this equipment, again, by help with the National Hydrographic Service. We had a funding together at that time. And so we spent the first months trying to understanding, but then we go on board and start measuring. And that was so important. Although sometimes there are some measurements like you can get afraid of how I'm gonna do it. I strongly recommend to go on board or to go on the dock and start practicing and measuring. And since 2015, we are collecting pH data. But after the National Hydrographic Service lent us the equipment of total alkalinity, we decided to start our own measurements of total alkalinity. And since we didn't have, and we still don't have yet, an automatic titrator, we decided to use the technique that other time series in Latin America, like Cariaco, was using, is by a spectrophotometric method using the same spectrophotometer we acquired. We are aware that this is not the best technique, but at least it's acceptable, and we can have intercomparations with other time series in South America. So we start measuring, we start our ocean acidification in situ measurements, and so I was in action. But really important is like, it takes time to understand the standard operation procedures recommended by the community. Not only you need to follow them, but also you need to take the time to understand the SOPs and also the equipment's manuals. Sometimes you get afraid when you see a huge manual, but it's really important to look at them and continue updating the techniques, and ask, like, if you have contacts with the seller, ask them if you have any doubts, ask your peers, and even ask the expert. It's really important. This community, ocean acidification community, is amazing, it's so open, and even the top researchers reply your emails and explain to you if you have any doubt. I was so lucky also to have a lot of trainings. Like I really encourage you to go to every training that you can attend. I was lucky to have several trainings in ocean acidification with really top scientists from Latin America and from around the world. Like we were lucky to have Martina Young, which was one of the last webinars, and to have Andrew Dixon, which is one of the most important researchers, and also to go to see, like in my case, since I'm measuring in situ, it's important to take the time to go on board to see if you feel comfortable with it, to see how difficult it is to measure on board, because sometimes techniques look simple, but you need to perform them on board, and it's not an easy task. But also, you need to learn how to use different data processing and data visualization platforms, because you reach a point that you have a lot of data that you need to polish. And you not only need help from the experts to lead you on how to do that, because it's not an easy process and it takes a lot of time, and you need a lot of accessory variables. Let's say you cannot process pH and total alkalinity without having the knowledge of temperature and salinity. So that you need to, by that, you need to interact with the physical oceanographers. And sometimes you may find values that maybe are outliers, but they have some underlying biological process going on. And for that, you need to really not to be alone and close. You need to interact with all your group. In my case, I'm lucky because our group, we have a lot of biologists, really expert ones, and also we have the physical cabinet, the physical oceanography cabinet that always help us to understand the temperature and salinity and what are the processes going on. But also, since CO2 is fluxes and interaction is really related with the atmosphere, it's important to make contact with, for example, atmospheric gas, as we call, to understand maybe the pressures that's going on, how was the day and when you were sailing, how were the waves, etc. But also, I think it's important to understand that you cannot be isolated. You need to join ocean acidification networks. They are really an amazing umbrella that help at least me, and I'm pretty sure a lot of peers, to not only to get trained, but also to get in contact, like face-to-face with the top scientists. And I think it's important while you still continue measurements to improve your knowledge in another ways, like trainings, platforms to process and data visualization. For example, for me, it was really important to understand how to program, because you need to deal with a lot of calculations, how to use the CO2Cs, which is one of the most important platforms for us that works in ocean acidification, but also to have really good knowledge about data visualization platforms. In my case, I use ODB, and it works perfect for me, but I mean, it's not restricted. But to keep that in mind, to run a time series and to maintain it, it means not only to measure, but also the other things you need to strengthen to get the best data. And talking about the trainings, I was like really blessed of having several trainings. I'm putting this slide because it's important, and this is all the people that I'm in contact with from the ocean acidification community, and they were like really, and they're still really helpful with me. I have an amazing experience last year, for example, through the peer-to-peer funding, to go to NOAA and discuss with Dennis Perrot and his group about ocean acidification measurements. And I have an amazing background trainings within the LAOCA community. So, okay, we have the training, we have the time series running out, but you need to have money for that. And for that funding, especially in South America, you need to understand that most of our sites of sampling are not known. We are just starting. So it's really important to have at least modest fundings to get instruments, consumables, but also to facilitate some trainings. And in 2014, we got a funding from the National Council of Science in Argentina and the Inter-American Institute of for Global Change Research to implement the measurements at the EPEA time series. And nowadays, we are so lucky to participate in the NANO Global Project, a global study of coastal productivity, desoxygenation, and ocean acidification at selected sites that provides a lot of opportunities, not only for funding for fieldwork and consumables, but also to organize these webinars. And there's something that I'm really proud of it. So we start our time series, we are running, and this is like the photo of the status of our discrete carbonate system measurements and EPEA. We are aware that there's a lot of holes in the time series, but we are continue doing it. Our time series, something I didn't mention, is like ideally is monthly, but of course, as Latin America and many other countries, development countries suffer, it's like we don't have a full availability of ships. We have political issues going on that may prevent us to go to visit our time series. But from now, we have already 23 cruises at the EPEA being performed. We are aware that this data doesn't cover a complete annual cycle yet, and it's just a starting point to get information about the possible interannual variations. But I wanted to show this picture, although it's for me simple, but it's really important. And as you can see on the top picture, there's some values of pH in April 2018 and in September 2016 that catch our attention. And we were able to understand what's going on. In September, it was the phytoplankton bloom, and in April, it was extreme heat that was going on in the area. And we are peeling under the surface of our values, and hopefully we will get soon results to publish. As I was telling, there's challenges of maintaining time series in situ observation in Argentina and in other development countries. The main difficulty is the frequency, and because the resources that we have dedicated to science, we don't have a lot of people being trained. For example, in my case, I'm the only one that I don't have a technician working with me in our group, so I need to perform everything from collecting the samples, preparing the cruises, and processing the data, so it takes more time. And we have several issues about getting supplies, even if you have the budget. For example, the NANO project gives us budget, and it's really difficult for us to get the supplies. And if we get them, it would cost at least double the price that Europe or United States. And when you have equipment, it's extremely difficult, close to impossible, to send instruments for calibration and reparation. But the most sad thing is, I think most of the time, is the lack of political will, that we need to encourage that, we need to change that. We cannot change bureaucracy, but we can show our data and our advances to get the politicians and the decision makers to understand this issue. So keep always in mind the big picture. Although it's difficult, maintain the commitment and enthusiasm. Is the way I see things can be done. And communicate your results to the scientific community. Although, let's be honest, I still didn't publish EPEA data. It's a work in progress. every year and every new data that I have, I share with my peers in conferences. And it was really helpful for me to understand some issues of total alkalinity, on some cases, some really slight things about pH. But also, I think it's important to translate the scientific knowledge into information that can be used by society to raise awareness and help with decision makers. Because we are aware that ocean acidification is a global concern at all levels, and it will affect all levels. And it's already been impacting several marine services. So, as an example of communication that we did with the NANO project was to put a banner in one of the most important beaches in Mar del Plata. As you see in the top right, it's really crowded. So last year at the 8th of January, we put that banner that has a QR code that young people can scan, and that leads to a webpage to explain the ocean acidification issue. And it was really, and it has a really big impact on social media, and we were so glad because it was a low-cost communication activity. It doesn't involve a lot of resources, just only imagination. And we were so happy that even like schools and people contact me months after that. So how can, I think this is a small sample of how a small action can have a huge impact on society. So nowadays we are running EPEA, we are communicating, and with the NANO Global Project, we decided to start a new time series, a coastal one, but running by citizen science divers. And it's been almost more than a year since we started. It's ideally bi-monthly. We were lucky enough to have a really nice contact with the Divers Club of Mar del Plata and the scientific committee of the Divers Club. And since then, we are sampling at El Beril, how it is called. That's really important diverse site here. And it's really interesting to relate with them and to translate, because we empower divers and citizen science, and we make them conscious about the sea. So I think this is really important to see, and it's simple. So, and also it can be an example, okay, you don't have a ship-based time series, but you can talk with the divers. If you are a diver, you can start running your own time series. And I think it's feasible. Okay, well, I think I talk a lot, but thank you so much for the opportunity of letting me doing this seminar, and thank you so much for being there.
Well done, Carla. It's really impressive. So you started from scratch?
Yes.
Yeah. Very nice. I don't understand a single thing about carbonate system or even instrumentation. I was wondering, so these instruments, are they staying in the ship, or you take them back to the lab and then back to the sea every time you go out?
Yes. So I'm gonna put the image. I'm searching for it. Let me see. So this is a portable spectrophotometer. It's, as you see, compared to my body in the picture, it's really small, and it was a good choice that we discussed with at the time with Cariaco Time Series Station and Laura Lorenzoni from the IOC. And we take it to everywhere we go, because we don't have a ship dedicated to EPEA, of course. So we have at least 7 ships that help us during our measurements, and sometimes they are opportunistic, but also you can put it on the lab and work with. There are some people that don't have the opportunity to take the samples on board and measuring on board, maybe because it's on boat, and you can set up this in a small table. You don't need that much, although every equipment has its bottlenecks, you know.
I see. And so I have one more question before I open, if you don't mind. So let's say that now I learn from you everything I need to know. What instrument should I purchase? Where should I start looking for funding if I want to establish or start to assessing the carbonate system in my area
Well,
for helping me purchase instruments? I mean,
for purchasing instruments, like GoAON, it's not for purchasing. GoAON is running a program. It's called GoAON on Kit through the Ocean Foundation, and they're helping a lot of development countries to start with the ocean acidification kit, giving equipments. IEIA.
The Inter-American Institute.
The Atomic Agency, International Atomic Agency, now is, since it's been years since it's helping the community, the ocean acidification community, to get not only training, but they already gave us many countries kits to start measuring. But also,
they distribute it to the countries, like you apply to get one, yeah?
Yeah, in what period they were doing that, but GoAON is now, it's leading through the Ocean Foundation, the kids. And it's really important to be in touch with the community. For example, Ocean Acidification Exchange page, it's a forum that you can get all the information, and they publish when there are micro grants, small grants for acquiring equipments, training. So it's really important to be on the community. The community is really rich and really open.
Is through a mailing list or a website?
No, it's a website. It's like it's a forum, a website but you can get like an alert to your email when somebody publish. You get different groups, and it's really nice. It's really nice effort. And also, there's a lot of platforms like Ocean Acidification blog, maybe run by IAIA. It's really sends you all the updates of grants, paper publish. I'm so glad I belong to a community that is really open and really transparent on that, you know.
Networking is everything, right?
Yes.
So we have a question here from Po Sang-chi. I'm so sorry if I'm not pronouncing correctly the names, guys. So this person is asking to you, what is the path length for the cell?
Well, I use 10 centimeters path length cells. This is, I think, one of the bottlenecks of the measurements. Spectrophotometric cells are not cheap, are really quite expensive. In my case, since I sampled directly from the Niskin bottle, I need a lot of them because I want to at least I need to have replicas in the 3 or 4 depths that we collect in our Timeseries. And sometimes they are fragile and they broke, but there's different alternatives. Since I have the cell holder of 10 centimeters, which is the most recommended, it is an ocean optics, and this is the cell that I use.
Okay.
And I see somebody post the values here now.
Yeah, Marta Alvarez got that right. So below her comment, Frederick Bonneau asks, please, Carla, what kind of pH meter and spectrophotometric are you using?
So I'm using an ocean optics USB 2000 plus that we acquired in beginning of 2015. There's another one now. I think the new generation is called Flame. There's another one, but the methodology is the same. I really find it nice because it's portable, and you can, if you don't have a lot of money to buy all at the same, like it's really expensive to get a high-tech spectrophotometer. The community we know that, but since it's portable, it has like different accessories. You can get the You can buy the main part one time, you can get the lamp then, you can change the fibers because it's an optical fiber-based spectrophotometer. It took us 1 year to acquire.
I'm sorry.
By parts.
Okay. He complements his question asking if you can give an approximate price of these instruments.
Well, the price depends on where you buy it. That's key, and I was mentioning. If you want to buy it here in Argentina, it would cost you $15,000. But if you get in Europe and in America, at least it's gonna cost a quarter less. Not including the importation fees, of course, you know. But you, as I told you, you can buy like different parts and they join it together. That's what we did. It was our example. I'm not saying it's the best, of course.
This so Constanza Lorente asks if you're thinking on giving a training about how to measure pH and AT in Argentina.
I wish it happens soon. Nowadays, now this year, we hope to, at least at the end of the year or maybe next year, to give some workshop. It's something that is pending. Last year, we had a nice interaction with Costa Rica, and we were there. I was there training the scientists there in San Jose de Costa Rica about these measurements. But it was more like a peer-to-peer transmission because they share the same equipment, you know? So setting up the equipment and explain them how to do it. And it was really nice for me because I needed to update in the technique, you know?
Yeah, I see.
So it was a really nice experience.
It would be good to have you teaching the Latin American.
Yes.
So Sarah Posing asks again, what is the holding time for pH?
Well, it fits for the purpose. When I started, I didn't know that I really, to be honest, like this is some of the issues. I didn't know that I can hold for some hours or some minutes. So I was running on deck after taking the sample and putting them to thermostatize and then measure it. But it depends. If you're gonna take the sample directly from the from the NISKIN to the spectrophotometric cell, are you gonna follow the SOP and taking the sample in a really nice and good borosilicate glass bottle? Are you gonna use mercury to inoculate the sample? Is your waters like really productive that you cannot wait for them? Is the temperature like really high where you're sampling? Like it depends. Really not like something.
General rule.
General, no, there's no general rule. But you need to protect from changes in temperature, like
the faster as possible.
Exactly, to protect the sample, to keep it in dark. And in my case, like I follow a protocol of waiting 1 hour from the time that I collect the sample, while the sample is being thermostatized before measuring, because we measure pH at 25 degrees following this SOP.
Okay, so Sarah Fowell asks, hi Carla, I was wondering what exactly the volunteer divers are doing. Are they collecting discrete samples or doing some ecological surveys? How is this program funded? Thank you.
So the divers are collecting samples. As I call them the Teniski samplers. They take the glass bottles to the place where they dive. That's called a beril, and they take samples. From now on, we are collecting at. They are collecting at 5 meters, and they are collecting not only for pH, total alkalinity, chlorophyll, dissolved oxygen, but also they are taking for salinity and phytoplankton and bacterioplankton biomass. So it's really nice. We already have 8 cruises, 8 visitings to Alberil, and it's really nice. Like, I'm really happy to have that, and it's funded by the NGP project that that is having this webinar.
So there's a comment from Samir Aliouan. He says, hello guys, I permit myself to answer. I'm working at the Villefranche-sur-Mer. We are doing ocean acidification research since several years here, and we use a Carry 60 spectra from Agilent Technology, which costs about 15,000 euros. Before, we were using a Spectra USB 2000 Plus from Ocean Optics, which is 6,000 euros, big difference. One cell, 10 centimeters spat length is 100 to 120 euros. So this is more or less about what you informed us. Marta Alvarez says, pH samples without poisoning should be measured within the same day, better within hours from sampling.
Yeah, well, in my case, I strongly recommend, depends of the productivity of the water, to measure as soon as possible. If you don't poison them, of course.
So Paul Sheng asks again, if in situ pH measurements are not possible, what is the maximum holding time for pH? Assumed sample will be measured from standard OA sampling bottle.
Well, depends. As I was saying, depends. There's some institutions that maintain them for some weeks. Andrew Dixon says, I remember we have an interesting, we attended a workshop that was Andrew Dixon present, and he was saying that you need to make it fit for your purpose. Which quality of values do you want? What is your infrastructure? Infrastructure. Like if you have, if you can keep the samples fresh and maintain without sun, you can maintain it a little bit more. If you follow the SOP and you close like really well the bottle, you know, your sampling bottle. So it depends. It really depends.
There's a whole discussion down here. So
yes.
Samir and Marta are very collaborating. So giving instructions on how to poison your sample and to storage in the dark, in a fridge. Very good, very well.
Yeah. In my case, like for example, when the divers go out, they take it takes for them 45 minutes to come from the sampling size to me when I'm waiting for them at the dock near the institute. So, and they put in a fridge box in a cooler. But and as soon as they come, I measure it. You know. But there are some people who save it in the fridge, and it's really good. Of course, avoid freezing, as Marta says.
Very good. Does anyone else have a question you would like to ask Carla?
Well, hi, hello everyone. I'm Hossein Smeti, the coordinator of the NANO Global Project. And I don't have really a question, but I wanted really to thank Carla for this really nice put together and presented and webinar. Thank you for your time, Carla, and all the effort put that we can see in your presentation. And also, as we can see from the comments and discussion, this is bringing there is a lot of interest about the subject. So I have one comment maybe that can join one of the questions that had been asked. It's about the citizen science part of your new station El Beril, like regarding like the divers participation in the NGB project. Did you have with them? Do you have or had with them like training session before when you were starting this citizen science project? Did you sit with them, talk with them about like the carbonate system, the ocean acidification? What's this important for? Did you give them some training on how to take them the samples and the bottles? And so yes.
Okay. Yeah. Hi, Hussein. Thank you so much for the comments. Yes. To get a citizen science, even a small project, you need to talk with them and really interact with the divers. And I was so lucky because there is a really close relationship between the Divers Club in Mar del Plata and INIDEP. And some researchers from INIDEP are divers in the club. So it's been years since we are talking, having talks together. They have a week of science, as they call, and I participate on them, and that's how I get to them, they know them. And I have a talk about ocean acidification some years ago, and one of the divers asked me, "How can we help you?" And so we start talking about doing something in common, something together. How can we do that? And so when we decide to have this citizen science project, I have several meetings with them, first to discuss where, when, and how, and then to train them with how to sample the bottles, not to leave bubbles, how to protect them. And I was so lucky that they even invite me to go on one of the boats. I don't dive, but I stayed at the boat and explain to them how to do it, and look at them sampling, and they send me tapes of how they were collecting the bottles. And this year we are planning to have at least 2 or 3 like short seminars to the rest of the divers, because nowadays the most expertise divers are going, but to open them to the whole club, we need to train them on how to collect the samples, and also which data to transmit to me. Is the weather, was the weather nice? Was the waves like really high? What was the temperature recorded in their sensors, in the diver sensors? There was a lot of waves, there was a lot of currents. It was hard for them to take the samples. Like at the beginning, we practiced with a lot of different size and shapes of bottles until they were comfy, because it's not easy to close, a bottle in the sea, inside the water. So it was really nice.
Cool. Thanks a lot. Yes.
Can I ask something?
Yes.
Now I'm curious about it. So they take from one bottle, you take all these measurements, the salinity?
No, I give them like 10 bottles, just in case. As you see, I'm gonna see if I can show you. For example, I don't know if you see this this photo. the guys is holding the soft oxygen bottle.
Yeah.
We acquired with the NGP project.
I remember those.
Yes, and I give them, for example, sometimes I give them different type of bottles depending on the diver that goes. Most of them are glass. That's something like really tricky, but I talked to them and they were feeling comfy, and it was not difficult for them to sample like in the typical dissolved oxygen bottle or total alkalinity bottle. And I also give them some tubes, as you can see in the top, in the bottom left, the blue tube with the cap. I give them several for phytoplankton and one huge dark bottle for chlorophyll. But we tried several because the pressure was ruining the bottles, the plastic ones. But yeah, and it's really nice. It works like.
Is this station close to the EPEA?
Yeah, well, it's quite close. I mean, EPEA it's 3 hours from Mar del Plata, and this is 1 hour.
Okay.
But this is more coastal. This El Beril has 20 meters depth, and EPEA, it's really dynamic. It has dynamic conditions, and because it's on the 50 meters isobat, so it's kind of coastal, but it's not that coastal.
I see.
Yeah.
Yeah, okay, Carla, thanks a
Hi.
lot. For just want again to stress how like important the work that you're doing, and like you just showed us showed case that even with the modest funding that, for example, the funding that we're having now, the NANO Global Project, even with a relatively modest funding, if you are, as you mentioned, if you have the enthusiasm and have the interest always up and always drawing attention to your project and talking about it and trying to bring more non-scientist people in, like the diver, the advantage with them is they are always pretty much every day, if they, of course, the sea conditions are good, they can go out. So it just takes some will and some enthusiasm to talk with them, to give some time, and there you go. You have citizen science, really people that are really interested and they are willing to help, go out to the sea, take the samples. So yeah, thanks a lot, Carla, for this great effort, and keep it up with the good work.
Thank you. Vivian wanted to say something.
Yes, hello everybody. First of all, thank you, Carla. Very good talk. Of course, I know all the insights, but I just wanted, from my side, having been involved into this NFPOGO from the very beginning, that I would like to thank these efforts, Lika, and of course, everybody behind this effort. And I would like to reinforce the message that Carla gave. I liked very much some very sort of cartoon blobs talking about teaching, experience, and passion. And I think that's the clue. You need to have passion, you need to have interest in doing, to overcome all the difficulties, especially in developing countries, to pursue these investigations. And at the same time, you have to be very aware of all the details of the measurements, because enthusiasm alone is not enough. You have to be very careful, otherwise these measurements will not be useful. But being overcautious and saying, until I have everything perfect, I will not start, it's not also very good. So you need to start mixing these two to evolve and learn. So I think that's the main message from this talk. So thank you, everybody. Bye-bye.
I thank you, Vivian. I agree. I think that Carla gave us precious tips here. And among them, I also highlight this looking for your networking. As Carla was saying, the ocean acidification, it's a very strong network. People help each other. And if you start small, you can have their assistance to modernize and going forward. So it's always a good idea. Okay, so thank you so much to everybody who takes part of your day to be here with us. A special thanks to Carla to put in the effort on this amazing presentation. We will, in the next few days, we're gonna upload this seminar in Pogo's YouTube channel, and we'll advertise this in Pogo social media and Nano social media. You can find our contacts on these websites, and please feel free to contact us if we can assist on everything. And yes, thank you.